All right, welcome to Solving Multi-Step Equations. This is one of my absolute favorite units to do because we got a lot going on here, and we're going to see how this compares with what we were doing before when we just had an expression and we are evaluating what's going on there. So remember, to solve for a variable, we have to apply the inverse operations that we know and love in reverse order, in which they were applied to the variable expression. So here I have GEMDAS, you might know it as PEMDAS, right? The order of operations starting with grouping symbols followed by exponents, and then multiplication and division in the same step, and addition and subtraction in the same step. All right, well, this direction over here, this is what happens when you're evaluating an expression. So like if I gave you something like 3 4 squared minus 5, that would help you with the order in which you would evaluate that expression. Now, going in the reverse, this is the order in which we are solving an expression. And let's actually just think about this equation I'm going to have you solve down at the bottom. So it looks like 3x plus 12 is 24. So if I'm thinking about the journey that my inputs take when they get plugged into this equation, the first thing that happens to them is they get multiplied by 3. And the last thing that happens to them is they get 12 added to them. So if I'm trying to reverse the process and think back, right? So the first thing that happened, right, is they got multiplied by 3. Then we added 12. If I want to work backwards to figure out, so I know, right, when I did those two operations, I ended up with 24. But if I want to work backwards and see how I got there, I need to undo everything in the reverse order in which it happened. So I would try to reverse this, my little undo symbol, adding 12, which would be by subtracting 12. And then I would be able to multiply by 3, or undo multiplying by 3 by dividing by 3. And then that's how I would get the number I started with by itself. So that's why we have to do things kind of in the reverse order. I tell my students it's like an ordered process, like putting on your shoes. So for example, you might put on your socks, then you might want to, then you would put on your shoes, and then you would tie your shoes. All right, well, if I wanted to get back to being barefoot, I couldn't just take my socks off, right? But I would have to untie my shoes, and then I would take my shoes off, right? And then I would take my socks off, but I would have to reverse the order as well as doing the reverse operation, right? I wouldn't be able to take my sock off through my shoe without taking my shoe off first. All right. So sometimes before we start doing our inverse operations, we might have some cleanup that we have to do, though, on one or both sides of our equation. So we may need to use the distributive property. Or we may need to combine like terms. To simplify one side of the equation before using any inverse operations. So this is a comparison here between what it would look like to do something on the same side of an equation where we're going to combine like terms versus when we would use an inverse operation. So here I have this 2x and x. those are like terms. They're on the same side of the equation. So if your teachers, they have you draw a straight line here through the equal sign. And so that means that we're going to do the addition, right, as is, as it appears, since they're on the same side of the equation, right? So that would look like 3x, and then it would be plus 12 still equals 24. Now, if I wanted to look at how we would use an inverse operation, notice here that there's nothing to clean up. If I wanted to solve for x here, this is a two-step equation, I would have to use an inverse operation. So if I wanted to get rid of this plus 12, I would subtract 12 from both sides, because that plus 12 and the minus 12 would cancel. Now, but the 3x is equal to 12. And then if I wanted to keep going to solve this equation here, I divide both sides by 3, and I would end up with x is equal to 4. All right, so let's look at our first example here of a multi-step equation. First thing that I'm going to look for is, are there any like terms that we can combine? So I'm going to look for combining some like terms. And I like to teach my students to annotate their work, where I'm going to do something on the left-hand side, or do my work on the left-hand side, and on the right-hand side, I'm going to write in what it is that I have been doing. So the first thing that I notice is I have negative 2x and 5x, and those both are like terms, right? They both have x to, so I can combine them, and I'll just add them as I see fit here. So I have that negative 2x's plus 5, so I have, I was in debt, right, 2, and someone gave me 5, right? So now I have 3x's plus 5 is equal to 14. All I did there was combine like terms. All right, well now we need to undo this addition, right? Since we're working in that reverse order of operations, we take care of any addition or subtraction first. So I would subtract 5 to cancel with this plus 5. But if I do that on the left side, I have to do that on the right side as well. And I'm going to end up with 3x is 9. And now I can undo multiplication. So I will divide both sides by 3 because it's the inverse operation, and I'll end up with x is 3. So if your teacher is having you check your work, what you would do is you would take this x is 3, and all the way back to the original, everywhere there used to be an x, you would plug in 3. Now remember your parentheses, right? So this wouldn't be, say, negative 23, but it would be negative 2 times 3. And then you would go ahead and multiply, evaluate that left-hand side, and see if it ends up being equal to 14. And that's how you would be able to know that your answer was correct. All right, now let's go ahead and do another example. Here in example 2, we have a set of parentheses here with multiplication out front. Okay, so there's technically 2 things that we could do here. You could get rid of that 5 that's multiplying right now by dividing both sides by 5. However, right, that 77 or we could also use the distributive property. So that's what I'm going to demonstrate here. So I go ahead and distribute. I draw arrows like so to kind of demonstrate that 5 is getting multiplied by x and 5 is getting multiplied by 2. So I'm going to end up with 5x plus 10 is equal to 77. And if I'm annotating my work, all I did there was use the distributive property. So I put that I distributed. All right, now I'm going to go ahead and subtract 10 from both sides, right? Always looking, kind of working from the outside in, working to get that x isolated here. And I'm going to end up with 5x is equal to 67. And so what I did there was I worked to undo the addition. And now I'm going to divide both sides by 5. I know what you're thinking, 67 is not divisible by 5, but that's okay. I'm going to plug that into my calculator. Remember, if you're using a TI, you can use the division symbol to mean a fraction. And we're going to get 13.4. And I always like when my students box their final answer, right? Not only so that I can see at a glance what their answer was, but they can as well when they're going back and looking at their notes later. All right, one more example, and then I'm going to let you do some work. So let's see what's going on here in example 3. You notice that left-hand side could use a little bit of cleaning up. I have this negative 3x and this 5x here. So I'm going to start by combining some like terms. And so it's going to look like 2x plus 4 is equal to negative 6. Notice I'm not using my line through the equal sign, right? I'm trying to kind of, like a training wheel, right? Remove that as we move forward. All right, now I'm going to get rid of this 4 here. So I'm going to subtract 4 from both sides. I'll end up with 2x is negative 10. So what I did there was I had to undo addition. And last but not least, I'll have to divide both sides by 2. And I'll end up with x is negative 5. And again, your teacher might be wanting you to check your work, so you would just go ahead, plug that back in at the very beginning in both spots where it was equal to x. And again, what we did there was we're working to undo multiplication. All right, so go ahead and solve the next couple of equations. I put together some good practice questions. So go ahead, take a few minutes, pause the video. Seriously, pause the video. I know what you're doing. You're pretending. And then come back and we'll talk about them. All right, welcome back. So let's go ahead and solve these here. So first thing is I'm going to combine my like terms here on the right hand side. Now we are probably used to variables being on the left hand side, right? But equality is a two-way street. It's totally legal to have them on the right hand side here. Now I have a negative 3 here, so I'm going to add 3 to both sides. I end up with 12 is 3x. Divide both sides by 3. end up with 4 is equal to x, which again is the same thing as saying x is 4, right? So I would totally accept that. Okie dokie. Here, I'm going to distribute this negative into my parentheses. We have x minus 4. And this is where you gotta be careful. This negative times the negative x becomes positive x equals 0. So now I can add those two together. I'll have 2x minus 4 equals 0. I can add 4 to both sides. I'll end up with 2x is 4. Divide both sides by 2. I'll get x is 2. Last but not least, here we can start moving the 2 over and then divide by 2, or we can distribute. I know a lot of times students' first inclination is to distribute, so if that's your instinct, let's go ahead and do that. Now I can combine these like terms here. I have a 10 and a negative 2. So I'll combine those first. I'll end up with plus 8 is equal to 7. I'll subtract 8 from those sides. I'll get 2x is equal to negative 1. And I'll divide both sides by 2. I'll get x is negative half. Alright, if you found these minutes helpful, don't forget to like and subscribe. And also check out the free solving multi-step equations maze that I have in the info box if you need a little bit more practice with solving multi-step equations.